Hi everybody, Dr. I here. We are going to get started with chapter 9. And again, these videos that I'm making for you are helpful for those of you who have been having connectivity issues. I know that it takes a lot of memory in order to run some of the programs that you need in order to do the totality of running all the functionality of the cameras and doing all of that kind of stuff with Kaltura. So this is going to be super helpful. And again, you guys can always come back to this video. All right, I am going to go into chapter 9 forecasting. So let's go there. Again, when you're getting ready for your midterm, it's going to be on all of the chapters 1 through 10 that we have reviewed thus far. Okay, so we're going to get ready for that. All right, guys, chapter 9, forecasting. Let's get going. So in chapter 9, and let me put this on a large screen, we are talking about forecasting. So, you know, when we're forecasting and when we're looking at forecasting, you know, what does it sound like? It is exactly what it sounds like. If it sounds like we will be looking to, and let me turn my volume up so I can make sure everybody can hear me. If it sounds like we will be, you know, talking about the future and how we can get to the future from where we are today, then you are 100% right. That's forecasting, right? Very simple. So we want to be able to articulate the value of our forecast, describe the attributes of what makes a good forecast, and be able to apply that demand theory that we've been talking about, and also use our forecasting tools, right? Those are always helpful. So using the past to predict the future. So, you know, we're always looking at past things that we've done, and that's very important for us because we want to be able to make sure that we take that into consideration so we're not blindsided by something that we could have easily avoided, right? So decision making needs to recognize the limits of forecasting. You can forecast, right? But there is probably going to be a little bit of error in that. Meaning, you know, sometimes it's useful to explore the what if forecast, which assume that the environment has changed. If the key outcomes change, it may be prudent to factor this uncertainty into decision making. So most businesses do rely on forecasts, and they do this in order to be able to try to tell what their future demand for their products are going to be and what their prices should be. The goal is to support decision making. And these what if forecasts can be helpful as long as they're close to correct, right? If they're not, then that's a big problem. So why do we forecast, right? We want to see the prices and the demand. So how many workers to hire, that's why we forecast. How much inventory to hold, that's why we forecast. You know, if it's inventory that is going to spoil or go bad, obviously we need to make sure that we have, you know, we have enough of it and that we don't have too much. So let's say you're doing a vaccination, right? You don't want to have 50% more vaccinations than you're going to be able to utilize because they're going to go to waste, right? That's going to be a problem. We also want to know what volume of supplies to get, what types of equipment, and what types of buildings, right? In order to house all of our stuff, etc. So our good forecast should be easy to understand, transparent, easy to change if we need to or modify. They should be accurate and precise. Unfortunately, these goals often conflict. So easy to understand forecasts may not be easy to modify or accurate. It's kind of like the iron triangle, right? When you have quality, cost, and access, how the heck are you ever going to balance all those things? Well, that you see the same thing with forecasts. If they're easy to modify, you know, and if they're accurate, precise, and transparent, that's going to be difficult. You know, easy to understand forecasts, again, may not be easy to modify or very accurate. Ideally, the methods would be simple. So decision makers could see flaws, hidden assumptions would be obvious, and nobody would be snowed. And by that, it means, you know, nobody would be taken by it, you know, and nobody would be taken by surprise. So it's the job of the analyst to make forecasts look simple. Just like it's my job to make all this information look simple, or look easier, at least, than your textbook makes it look. So for example, a complicated model can be described as assuming the next year looks much like last year, right? So we want to make sure that we are taking information that's hard and making it easier. It's pretty much it. Transparent. So what do you think of when you think of transparency, right? Well, you think, hey, I could see through this. I can get to the point. I can figure this out, right? It's transparent. So transparency is closely tied to simplicity. Hey, that's easy. I get that. It's simple. It's not hard. It's easy to see. So the audience needs to know what you did when you're forecasting. So what was your approach? What data did you use? And, et cetera. So you want decision makers to ask the hard questions. When we're talking about easy to modify, what does that mean? Well, how will a forecast change? So if a key assumption changes, how will that, change our forecast? If the key data changes, how will that change our forecast? And we have an example down here. You forecast a sales growth of 8%, assuming the economy grows 3%. But what if the economy only grows 2%, right? Then you're going to have to change that sales forecast is going to change because you assumed a whole extra percent there, which could actually be a lot. Anybody who owns a home knows that your interest rate really matters. And there's a big, huge difference between even something like 3% and 4%. It's, hundreds of thousands of dollars of interest. So, it is very important. Accurate and precise. So since all forecasts err, which means, they're not perfect, there's a trade-off. If you have accuracy, the forecast interval includes true value, right? In precision, we see forecast intervals that are very small, okay? So accurate and precise, we're looking at the difference between accurate and precise, okay? So you could have an accurate, imprecise forecast or a precise, inaccurate forecast. And we'll look at that in a second. If you're thinking to yourself, I have no idea what this lady's talking about, hold on one second and I'll show you. So an accurate, imprecise forecast, right? So say you say sales will increase by 0 to 10%, right? Well, that's not very precise. 10% is a really big range for you to tell me about. Like you're giving me, that's a huge, huge gap, well, that's a whole 10%. That's a lot. Sales increase 1%, so the forecast would be accurate, right? But you had such a large gap here. That was such a large margin for error. That's huge. You had 10% to play with there. So the chances of you getting that correct were pretty good, right? So it's accurate, but it was very imprecise. But let's say on the other hand, you have a precise forecast, but it's inaccurate. So let's say you go for it and you say, I'm going to try and shoot out a number. I'm pretty sure this number is it. Sales will increase by 2%, right? That's very precise. You didn't have a huge range there. You didn't say, oh, it's from 0 to 10%, right? You said it was 2%. But then sales only increased by 1%. So then that made your whole forecast inaccurate, right? But you're probably asking yourself, well, isn't the second one more helpful because at least it was closer, right? I didn't have such a large, but that's really just what we're talking about. You could have an accurate, imprecise forecast because you had such a large percentage range here, or a precise, inaccurate forecast. And there's many different ways to forecast. So the right one will depend, of course, upon your circumstances. So there's two different kinds of main methods here. There's qualitative and quantitative. So the qualitative method is more subjective, while the quantitative method, is numbers and mathematics and things like that. And the best way to describe this, to make it very easy and not to make it a big, huge thing, because you guys know that I like to show you things in very simple, easy ways. I'm going to pull over the Delphi Method video, which is only a couple of minutes here, so we can go ahead and we could see that.
The Delphi Method is a structured communication technique or method, originally developed as a systematic, interactive forecasting method which relies on a panel of experts. The experts answer questionnaires in 2 or more rounds. After each round, a facilitator or change agent provides an anonymous summary of the experts' forecasts from the previous round as well as the reasons they provided for their judgments. Thus, experts are encouraged to revise their earlier answers in light of the replies of other members of their panel. It is believed that during this process the range of the answers will decrease and the group will converge towards the correct answer. Finally, the process is stopped after a predefined stop criterion, for example number of rounds, achievement of consensus, stability of results, and the mean or median scores of the final rounds determine the results. Delphi is based on the principle that forecasts, or decisions, from a structured group of individuals are more accurate than those from unstructured groups. The technique can also be adapted for use in face-to-face meetings, and is then called mini Delphi or estimate talk estimate at.
Okay, so I don't want to play that whole video because it is kind of long and unnecessary. But what it basically told us about the Delphi method is that it's based on the principle that forecasts or decisions from a structured group of individuals are more accurate than those that aren't. So what they do is they pull together a whole bunch of experts, right? They have them answer questionnaires in about in about 2 or more rounds. After each round, the facilitator provides a summary of all of the experts' forecasts from the previous round, as well as the reasons for why they made that judgment. So the experts are encouraged to revise their earlier answers in light of the replies of the other members on their panel. It's all anonymous, so there's no, there's nobody arguing, there's no feedback, there's no I'm right and you're wrong, stuff like that. So it makes it easy. It is believed that, during this process, the range of the answers will decrease and the group will converge to one correct answer. They'll all concede and say, yes, I feel like this is the right answer. So the process is stopped after a predefined stop criterion. So either a number of rounds or if they reach a consensus or something like that. And then we look at the mean or the median scores of the final rounds to determine, the results. So they find this technique good for business. It's an interactive forecasting method, and it does rely on a panel of experts. So it can be adapted for face-to-face meetings, and when it is adapted to face-to-face meetings, then it's called that mini Delphi, or the estimate talk estimate, the ETE. Okay, and it is widely used in business forecasting, and it does have some real good advantages. So under the qualitative methods, that's the Delphi, because it's subjective. You're asking a panel of experts, and they are giving you answers, and they're coming together to decide, what the ultimate answer is. They're seeing other people's anonymous answers, and they're like, okay, you know what? Maybe I'm going to go in this direction. And once they reach a consensus, or once a certain amount of rounds have been done, they come to a consensus. You also have focus groups in that area. Under quantitative, you have simple extrapolation. Now, I want to show a video on this one really quickly, just so you guys, and I'm not going to play the whole video again because it's just too much time. It's too timely. But this really explains it really quick and easy for us. So let's play this really fast also.
Extrapolation is the process of finding a value outside a data set. It could even be said that it helps predict the future. To help us remember what it means, we should think of the part of the word extra as meaning more data than what we originally had. This tool is not only useful in statistics, but also useful in science, business, and anytime there is a need to predict values in the future beyond the range we have measured. There are several methods for extrapolation, but in this lesson, we'll focus on linear extrapolation, which is using a linear equation to find a value outside a data set. Let's try a basic extrapolation by finding values in a numerical sequence. When using extrapolation, we look for the relationship between the given values. So let's look at the following numerical sequence. What is the relationship between the values in the sequence? 2, 4, 6, 8, question mark. Pretty easy, right? The numbers in the sequence are increasing by 2. Now, by using extrapolation, we can predict the 5th term in each sequence. The 5th term of the sequence is 10. However, extrapolation goes beyond estimating future values in numerical sequences, as we will see in the next example. My friend Mary planted a bean plant, and she has been measuring and keeping track of its growth for the past 4 days. Based on her observations, she wants to estimate how...
Okay. So, then that's great. That's all we needed from that. So what does it mean? And let's go back to our PowerPoint here. Extrapolation. It just means that we're looking outside of the data set. We're trying to predict that next move. So, as we saw, what would be next in 2, 4, 6, 8? Obviously, it would be 10, and that would be outside the data set. All right. So that is one of the quantitative methods of forecasting. And I think that was a great example because it was quick and easy. The next thing is moving averages. And I also have a good example of that in a video that I like quite a bit. And it's only a couple minutes here. So we're going to watch this. This is moving averages.
In this video, we'll be talking about moving averages as one of our methods for forecasting. Essentially, with moving averages, what we look at is we say, let's take an average of the previous certain number of periods, right? Whether it's 3 periods, and we're going to say, okay, let's take a look at just the last quarter or whatever it is, or maybe we're going to do the last 6 periods. Or
now, when he says periods, if you look over here, it's months, okay? And quarter. So when you're talking about a quarter, there's 4 quarters in a year. So 3 months is 1 quarter. Okay. So when he says period, he's just calling these months periods. Okay.
Or maybe even 12 periods. And then we're going to essentially just say, okay, let's average all those and then let's move on. And so in this example, what we'll do is we'll look at the previous 3 periods. And so the first period that we'll actually be able to forecast using a 3-period moving average would, of course, be the 4th period. And so we'll just come in here and we will take a look at the average of periods 1 through 3. And again, over here in the right-hand column, or in column F, what we've got is we've got the percent difference between the forecast and what our actual number was.
Okay, so this is really simple. All we did here was average these. So you take 11,367.91, 12,376.47, and 15,433.65. Add those together, divide them by 3, and you're going to get the forecast for the 4th month. Now, the forecast would have been 13,059.34, but the actual sales, 16,235.66. That's a 24.32% difference, right? So it's about 16 from 13 is about 25% more. Okay, and he explains it also, but I just wanted to do that really quickly.
Our actual sales. So the data that we've got here is data from a small product line at one specific location, and so what we're looking at with the numbers is essentially the percent difference says that our actual sales were 24% greater than what we forecast that they were going to be. And so we'll go ahead and we'll drag this down, and we'll see how this compares to the naive approach that we had mentioned in a previous video. And so as we take a look through the percent difference, we've still got some pretty large percent differences. This is notably one of the largest here. So 94% difference between what we had done here as well as the other. Now, one of the reasons that a moving average might be this far off, 100% off or things, is specifically for this product line, we're looking at some seasonal data, and so a moving average wouldn't show us year-over-year growth. It would probably just show us, of course, the last few periods, and then let's average those few periods. And so some of the things that you can do, of course, with moving averages is you might take a look at, okay, what was period 1 last year, the year after that, and the year after that. Another thing that you could do with moving averages is you could do a weighted average and say, okay, the most recent period, based on our growth trend or our growth trajectory here, the most recent period, we're going to weight that 50% of the total. And then we're going to give a 30% of the total and maybe 20% of the total. So we could do a weighted average as we do some forecasting, and that would probably get us a little bit closer to being more accurate. But essentially, that is moving averages and the method of, or at least the basic method of using moving averages for forecasting.
Okay, so that was moving averages, and he actually mentioned and started to go into weighted averages, which is where we're going to go next here, because it's just a great segue. So I like Investopedia when you're just, going to look up some additional items when you're talking about business, or the like, because it's very simple to come in here and to take a peek. And they explain things very easily, very well. It's very simple. So the weighted average is a calculation that takes into account the varying degrees of importance of the numbers in a data set. So the weighted average takes into account the relevant importance or frequency of some factors in a data set. It's sometimes more accurate than a simple average, and stock investors use the weighted average to track the cost basis of shares bought at various times. So as he said in the video, a weighted average can be more accurate than that moving average. So let's take a look at the video because this is really going to help us to see what we're talking about.
A weighted average is a method for averaging several pieces of data with unequal importance or consequence. In a weighted average, each point of data is assigned a corresponding weight multiplier that can be determined by many values, including importance, scarcity, difficulty, and quantity. Stock indices offer a great example of weighted averaging. Because of the disparity in price of the stocks represented on an index, such as the Dow Jones Industrial Average, the price swings of higher valued stocks could disproportionately affect the average of the index, even though the swing in percentage for that individual stock is actually minor. By using a weighted average, the lower priced stocks can have an increased effect on the average, thereby equalizing the data measurement. For example, Sam wants to get the average cost of widgets he has on hand. He has one set consisting of 100 widgets at 25 cents per piece. Another set of widgets costs 30 cents each, and he has 75 of them. He then multiplies his 25-cent pieces by 100 to get $25, and his 30-cent pieces by 75 to get $22.50, totaling the cost of his inventory at $47.50. Dividing the total value of his widgets with his quantity, Sam calculates the average cost to be roughly 27 cents per piece. This method allows him to account for uneven quantities and fluctuations in costs.
Okay, so there we go. So, right, not as difficult as it seems. So in calculating a simple average, all numbers are treated equally and assigned equal weight, but a weighted average assigns weights that determine in advance the relative importance of each one of those things. So again, when they were breaking down the burger in the beginning, everything was weighted differently. And when you think about a weighted average like that, it is kind of true. Like how much do you like the lettuce? Like if you were going to eat a burger or make a burger at home, and you didn't have any lettuce, would that stop you from eating the burger? I mean, typically not, right? You would still make the burger anyway. But if you didn't have the meat for the burger, well, that would weigh on you a little bit differently. You would say, well, I can't have a burger if I don't have any meat, right? How would I do that? Okay, and again, we just talked about the Delphi method. That's where you take an expert panel of folks and you give them questions to answer anonymously, and they can see the other people's answers, and then you keep going in rounds until everybody comes to a consensus, or you've gone through as many rounds as you wanted to go through. And people find that, good in business. Okay, in market research, people have panels, questionnaires, surveys. You guys have taken surveys before, right? The school asks you to take them, and you're like, oh gosh, not another survey, right? So, you guys are used to surveys in that kind of a way. All right, so again, in qualitative forecasts, we're looking at basically subjectivity. You're looking for experts, right? You're looking for people who are knowledgeable to give you advice. In quantitative forecasts, we are looking at, extrapolation. So we're looking at, data sets, for example, 2, 4, 6, 8. What comes next in the data set? Well, if it's 2, 4, 6, 8, I'm going to go ahead and say the next number outside of that data set, right, extra, would be 10, right? And that's your simple extrapolation. Model-based methods are also used in quantitative forecasting. So you have your time series method, for those of you who make sure that you read this stuff in advance, like technically we are supposed to, I think the book does a really good job of talking about these. So a time series is a sequence taken at successive equally spaced points in time, right? So it's a sequence of discrete time data. If you want an example of maybe what a time series would look like, we look at the heights of the ocean tides, right? The tides come in, the tides go out. We have high tide, we have low tide. That's a time series, a good example of a time series method. Things like that, right? So that's actually pretty simple to note there. In forecasting, we take models that fit into historical data and use them to predict future observations. So descriptive models, or what we would call descriptive models, borrow from the future. They only seek to best describe that data. Okay. And it also talks about trend and seasonal decomposition, as well as multiple regression. Now, I want you to be, don't be scared of all of this. It's a lot of information, I know, and it goes into probably much more detail than what we would actually need for ourselves in this class. So I'm not going to go into huge detail with it, but I like to have it for you guys to build upon, because I think that's important. To know the basics of this and to be able to move on and say, okay, you know what, I've heard that before. I remember talking about that. So that's a really good thing for you guys. So when you're talking about trend and seasonality, the increasing or decreasing value, in the series is called the trend, right? And in seasonality, the repeating short-term cycle in the series would be called the seasonality. Okay, and we don't really go into too much detail there. So again, we talked about simple extrapolation, percentage adjustment, and then that moving average that we just talked about. So in simple extrapolation, sales will increase by 2%, right? So we are just really saying, a very easy way to understand something. So easy to understand, easy to modify, very precise. That's the good thing about simple extrapolation. Easy to understand, easy to modify, very precise. So in our data set, 2, 4, 6, 8, what comes next? 10, right? Easy. So what's bad about simple extrapolation? It doesn't sound like there's much, right? Well, when you think about it, it's not really transparent. So why 2%? It's unlikely to be accurate if there is any change in the environment at all. 2% is extraordinarily precise. And we don't know why we chose 2%. So, on the good side of things, what's good about this forecast, it's easy to understand, it's easy to modify, and it's extremely precise. But what's bad about it? Why 2%? We don't know. All right, moving averages. And we talked about the moving average, in the video. Pretty simple to understand. You take the 3 periods before and you average them together to figure out what you're going to be looking at in the 4th quarter or the 4th period, right? So what's good about a moving average? It's easy to understand. It's easy to modify. It's very precise. So what's bad about it, right? And this is just the equation. And you guys know that there's always some kind of crazy looking equation that goes along with these. So here's what the sales will equal. And when you're looking in Excel, all that really meant was, you saw him put in the word average in the parentheses, and the average was equal to the fields. So field 1, 2, and 3, right? It just took the average of those fields. So it looks a lot fancier than it actually is. So what's good about this forecast? Again, it's easy to understand. It's easy to modify. It's just an average. You guys know how to do averages. We all know how to do averages. It's not that difficult. But what's bad about it? It's unlikely to be accurate if there's any change in the environment. And as we saw in the video, once he pulled that line down and it autoed all of those future forecasts in the moving average, we were way off. Sometimes 108% off in those percentages. So in that percent change between the actual sales and what was forecasted. So that could be a bad thing if it's not accurate, right? All right, the weighted average. So again, sales will equal, a crazy formula, which looks a lot harder than it actually is because, in the video, we saw that all we really did was, average out, make everything more, more equal. So sales will equal, that equation. What's good about a weighted average? It's easy to understand. It's easy to modify. It's very precise, right? So that's good. So what's bad about it? It's not clear where the weights come from. It's unlikely to be accurate if there's any change in the environment. So where do the weights come from? How do we weight, tomato more than lettuce? Or how do we weight the onion more than, if you weighted the onion more than the actual burger patty, from the video? In the example, how would you do that? Where did that weight come from? It wouldn't be clear where it came from. So what's bad about it? Where do the weights come from? We don't know. And regression-based forecasts. So regression, anytime you hear about regression, you're talking about we're looking back, right? So the weights in this part come from the statistical analysis. So we take a statistical analysis, we do our funny equation. What's good about regression-based forecasting? It's based on all the information that you have, right? So we look back at all of the information that we already have, right? We regress, we look back at our data we already have. So it's very precise. It can incorporate seasonal effects and trends and things like that. But what's bad about it? Many managers don't understand it. It's unlikely to be accurate if there's any change in the environment, right? So again, it's got good points, it's got bad points. So again, how can forecasting go wrong? Well, if we look at the laws of forecasting, the future will be like the past. So changes can make our forecasts terrible. Look at what COVID did. You know, nobody would have forecasted the disaster that happened in COVID, but it happened, right? So, you know, as you can, you know, if you were thinking, oh, your sales were going to be so fantastic, let's say you owned a restaurant and you said, you know, for the past 5 years, we've been trending up, we've been selling more folks have been coming to our restaurant. We were on the Food Network maybe or something like that, and we have so many people visiting and this is wonderful. And then COVID hits, and that change in environment caused a terrible disaster, right? So, you know, if you think the future will be like the past, you know, changes in your environment like that can make your forecast terrible because, you know, folks who were doing really good in the restaurant industry and business went from, you know, crazy great revenue and sales to nothing at all once that happened. So really terrible. And, you know, forecasts will be wrong. So true, even if the forecast is like the past, true if the data are noisy. So forecast, and all that means, that's fancy talk for you could be wrong. So what are the implications? You know, forecasts identify likely outcomes. Likely outcomes, it doesn't mean that they're actually going to occur. It just means that they're likely. Some outcomes will be more likely than others, and even unlikely outcomes may occur. So, you know, let's say that you get your vaccination, for example, right? And they say, the CDC says, well, if you're vaccinated, you have a I don't know, let's say 90%, you know, chance that you will not, you know, contract COVID. It's very unlikely, in other terms, it's very unlikely that you would be fully vaccinated and get COVID, right? And then you got COVID. So it was unlikely that that would be the outcome, but that's what happened. That's when forecasts go wrong, right? So the goals are to support decision making and try to reduce that uncertainty, but even unlikely outcomes can occur sometimes. So even if it's unlikely, you know, it can happen. Think about the people who have triplets or like multiple babies, right? That's unlikely. That's extraordinarily unlikely, and it happens. So, you know, if it's unlikely, but it still happens, you know, that's where forecasting goes wrong. And then it just shows, like, you know, who would predict this? It just shows the previous quarters, quarter 1, quarter 2, quarter 3, quarter 4. This is 1 year. Say this is 2017. This is 2018. This is 2019. This is 2020. Look what happened. This could have possibly been, without a doubt in my mind, and this is sales. Let's say this is 200,000, 300,000, whatever it is. So this is like, you know, money, this is quarters, periods, right? So this is the past 3 years. And then COVID happens and it goes right downhill. It goes right up. So who would predict that? And the answer is nobody. Because if you look at the past, I mean, you dropped a little bit below 200, but that was your lowest point. And then you kept trending. But even when you did, you know, go from really good to not so good, it wasn't such a large, ridiculous drop there. So nobody would really ever predict that. So we need to forecast future values, and we need to make sure that they're as accurate as they can be. So why is it crucial to estimate, you know, forecast error? And all this means is that we have a opportunity to be correct, and we also have an opportunity to be wrong, right? So when you're talking about forecast error, you know, and it says in Q1, so in quarter 1, the estimate was 2,400 resident days. So physical capacity is 2,800 resident days. Nursing capacity varies with staffing. Hiring lead time is 30 days. How are these two estimates different, right? And what this is looking at is it's saying, you know, we need enough nurses to work with our residents, right? So we can't be that far off, or we're going to have a big problem, right? So when forecasting error happens, it turns out to be you know, a lot of it of a very messy situation. So, you know, in statistics, a forecast error is the difference between the actual or real and the predicted or forecasted value of a time series, or, you know, some other phenomenon. So what we do is we calculate the mean absolute deviation. And basically what that means is that it shows the actual demand versus the forecasted demand in units, right? So actual versus forecasted. What makes these two things different? 9 and 2. That's 700. That's a 700 difference. That's a lot, right? So 2,400 residence days plus or minus 200, right? When the physical capacity is 2,800, this is still good. But if you are plus or minus 900, if you're plus 900 and the physical capacity is only 2,800, let's say you're plus 900, you're over your physical capacity, right? So that's not a good thing, right? So that would be a problem. So again, you know, it takes the absolute value of forecast errors and averages them over a period of time. An acceptable error, you know, and you are looking at plus or minus, right? So you want to be not very wrong to make it, you know, very easy to understand. It's important to understand forecasting error because it does provide feedback to improve forecast accuracy. So it's super important. You don't want to be so far off that, you know, you're over your physical capacity, you know, in anything. Okay. So the forecasting process. So set the goal, choose a reasonable model. You have to be able to collect your data and analyze it. So you have to have access to all of that. Share the results with the decision makers and revise the forecast as new data arrives. Advice for forecasters: you will be wrong. Be able to explain why, be humble, which a lot of people have a problem with, and track factors that affect your forecast. The goal is to support decision making. Forecasting is not an end in itself. You know, people get all sorts of upset when they're wrong. I don't know why. It's not okay for you to be wrong. It is okay for you to be wrong. You do not have to be right 100% of the time. It's okay to be wrong. People think that, you know, they feel stupid, or, you know, you're not always going to do everything perfectly. You know, sometimes we have a moment where, you know, we knew what we were going to say and we forgot, or we knew what we were going to do and we forgot, or we did our best at something and we did it right, but we were wrong. Right? So when you're forecasting, you're doing your best to forecast, but you're working with what you have, and sometimes you're just not right. Sometimes the environmental changes throw you for a loop and you're just not right. So you have to be humble and understand that, you know, you're not always going to be right. And it's the smartest person who realizes that they're not always right. Right? So forecasts are important, but they're just tools, and they could be right or they could be wrong. Combine judgment and history. So your forecast should be consistent with the demand theory, explicit about their assumptions, and explicit about how precise they are. So you're trying to make them easy to understand, transparent, easy to modify, accurate and precise, but that's very difficult to do. It's like saying, hey, our healthcare system should have quality, everybody should have access, and it should be cheap. Right? Those three things are never going to be in balance. So unfortunately, those goals often do conflict. And we went over our qualitative and our quantitative forecasting techniques. Okay, so that is your Chapter 9 forecasting. So what I hope that you take with you from this course, and what I tried to highlight really here was the Delphi method. You will see the Delphi method using that that expert panel, right? You'll see that once you guys start to get closer to your capstone course, because that comes back up in strategic management and things of that nature. So that was your Chapter 9. That was your forecasting. And right now, I think it is a super good time to go ahead and to take a break. So let's take a break, and then we'll come back and we'll look at Chapter 10. All right. Thanks, guys.